Okay, so we want to start talking about dividing with polynomials. And we won't go through the full story, but we'll get to the point where we can divide by um, monomials. So what we want to talk about in this video, I decided to break it into two shorter ones. So these are the exponent laws for division. Okay, so if you remember, for multiplying, we had some exponent laws that kind of drove the whole process. And that was that exponent law 1 said that if you're multiplying two things with the same base, then you add their exponents. Okay, and then exponent law 2 says that if I have something with an exponent, but I raise that to an exponent, then I multiply the exponents. And then the third one says that if I'm multiplying two things and I raise that product to an exponent, I can distribute that exponent onto each one of those bases. All right, so those are the first three exponent laws for multiplying. And now we want to talk about some that apply to division as well. Okay, and the basic one that kind of resembles law 1 has to do that if I have something raised to an exponent and I divide it by the same thing raised to a possibly different exponent. Okay, and if you remember the video I did on these laws, to see how these laws work, you can look at a basic example. Okay, and so say I have something like x to the fifth divided by x to the third. All right, and so what I can do is I can just think about writing out that definition of what x to the fifth means. It just means x times itself 5 times, like that. And then x to the third means x times x times x. All right, now if you think about how things cancel or reduce, any pair of x's in the top and the bottom, they actually reduce. So I can get three pairs of x's to cancel out in the top and the bottom. And so what ends up happening is now I just have x times x, which is equal to x squared. All right. Now, how could you see how to get that 2 from the original so that you don't want to have to go through this process every time, because you're going to see problems like x to the 15th over x to the 7th or something like that. So you don't want to have to write that out. So let's see if there's a shortcut here. And if you look at that carefully, we started with an exponent of 5 and 3, and we ended up with an exponent of 2. How do you get that? 2 is equal to 5 minus 3. All right, and so that's what the exponent law says, is that if I'm dividing two things that have the same base, then I can subtract the exponents. Now remember, it's important to subtract in a correct order, and so you do the top exponent minus the bottom exponent. And so that's the exponent law that we're looking for, number 4. Okay, now tied into this, you might be able to think of some weird things that might happen since you're doing subtracting. Okay, and so we're ready to talk about law 5, and it's something that doesn't seem to make a lot of sense until you see this. Okay, so let's look at an example of this too. What we're talking about here, basically we want to say what the 0th power means. What does it mean to raise something to the 0th power? Okay, well, the way to get this from the exponent law is to look at something like x squared divided by x squared. Okay, and we've been saying this all term long. Anything divided by itself is equal to 1. So in one sense, this is equal just to the number 1, just by our normal, I remember talking about this, I think on day 1. Anything divided by itself is equal to 1. Okay, but by the exponent law, we would say this is x to the 2 minus 2, which is x to the 0. And so what we're seeing here, forget all about all this stuff in the inside, we're just seeing that 1 is equal to x to the 0. All right, and so for some reason when we write the exponent laws, we usually use a as a base. So anything raised to the 0 power is equal to 1. Okay, so make sure you realize this applies to numbers too. So 3 raised to the 0 is equal to 1. Okay, now there's one quirky thing you got to be careful of though. If I write negative 2 to the 0, all right, if I want that negative 2 to be incorporated as part of the 0 power, i.e. if I want to get 1, I need to use parentheses. Okay, otherwise, this is especially important on calculators. If I just write negative 2 to the 0 or just type negative 2 to the 0, because of the order of operations, your calculator will do 2 to the 0 first. 2 to the 0 is 1, but there's that negative in front of it. So be careful of that, especially once you get into some homework. There's a difference between these two expressions. So this is a single number raised to the 0 power, so this law applies. This second case without parentheses is just 2 raised to the 0, which is 1, but then there's this negative you have to carry over to the right side as well. And then there's one other exponent law. It deals whenever you are dividing two quantities and you're raising that to a power, like that. And this is very similar to law 3. All right, so but just to help you see it, say I have x over y, and I want to raise that to the third power. Okay, well the third power just means to multiply something by itself 3 times. So I have x over y times x over y times x over y. But if you remember, whenever we multiply fractions, we just multiply straight across. So I could just make that all one big fraction part and put times in between each one of those. Well, in the top I have x times x times x, which we can write as x to the third. And then same thing in the bottom with y, like that. So what we're trying to get at here is that whenever I have a division raised to an exponent there, then I can essentially just distribute that exponent onto each one. Okay, and so what does this exponent law say? This is a to the n over b to the n. Okay, and so that's the exponent law 6. And if you want them all in one place, in further classes you might look at one other exponent law that deals with negative exponents. We're not going to get into that here. But the exponent laws are that if you're multiplying two things that have the same base, then you can add their exponents. The second one is that if I have something to an exponent, but then I'm raising that to an exponent, I multiply the exponents, like that. The third one is that if I'm multiplying two things and raising it to an exponent, I can distribute the exponent onto each part, okay? And then the fourth one is that if I'm dividing two things with the same base, then I do the first exponent, or the top exponent minus the bottom exponent. And then the fifth one is that anything raised to the 0th power is equal to 1. And then lastly, we have that written up above. But if I'm dividing two quantities and I raise that to an exponent, this is the division equivalent of law 3, like that. Okay, now again, be careful about 3 and 4 and overusing it. These are properties that just apply to multiplication and division. These don't apply to addition and subtraction. So whenever you're adding inside of a parentheses or subtracting, you can't just distribute that exponent onto each one of them. And we've seen examples of that. Okay, so especially if you take notes, there's a nice place right here just to take note of all the exponent laws in one place. So just a couple quick examples to illustrate some of these. So this just means we're just saying to simplify things. And so first of all, make sure you realize things do apply to numbers, although we more often use variables. So I could have something like 11 raised to the 12th power over 11 raised to the 7th power, like that. Okay, the key thing is that I have a single base. I have the same base and I'm dividing. So I would use exponent law 4 here, and I would subtract those exponents. So I'd have 11 to the 12 minus 7. That's 11 to the 4th. And as I mentioned before, sometimes we'll just keep it written that way, and sometimes we'll actually compute it. If this number is fairly reasonable to compute, we'll go ahead and compute it. And just remember on your calculator, if you do want to compute that, you do 11, and there's that caret symbol to the 4th, like that. If you go and compute that, you get 14,641. Like I say, it just depends on what you're trying to do in the bigger picture. If actually knowing the value of this number is important, then we'll go ahead and give it. Sometimes it's just important to realize that this is a power of 11. So sometimes we'll leave it that way. And of course, if you want to cover your bases, just give them both. All right? And so then, but we can apply this same stuff to variables here. And so we have, I could have x to the 8th divided by x to the 7th, like that. And so in that case, I would do x to the 8 minus 7. That's x to the first. And remember, if we have an exponent of 1, we usually don't write it. All right? And then equivalently, I could have something like y to the 4th divided by y. Okay? And just remember, why is this applying here? Because whenever we don't write an exponent, that means the exponent is equal to 1. And so I just do y to the 4 minus 1, which is y cubed. Okay? Like that. Now, some related examples kind of combine things. And so I could have something like x to the 14th times y to the 8th divided by x times y to the 4th, like that. Okay, like that. The key thing is, and I'll explain this, what you can do is you can break it apart into the two separate parts for the variables. Okay, like that. Okay, the reason you can do that, if you're wondering, is think about going backwards. Think about starting here and going to the left. You're multiplying fractions, so you multiply straight across, and so you would just end up with this expression right here. So we're kind of going in reverse from a multiplication. Why is that advantageous? Well, first of all, we have x to the 4th over x to the 1st, so they have the same base, and so that would be x to the 14 minus 1, which is 13, and then I get y to the 8 minus 4, that's equal to 4. So make sure you realize that 4 came about from subtracting those two exponents. So that would be the answer there. Being a little sloppy, I wasn't circling my answers, would I? Okay, so we could have something like that. And then we could play around with the fifth exponent law. You could see something like 8 raised to the 0 power. Well, that's anything raised to the 0 power is equal to 1, like that. All right, and then I could have something like, I could say negative 6 raised to the 0 power. Just be careful here. You might want to type these in on your calculator just to see that too. So on your calculator, you would hit the negative key, hit 6 raised to the 0. Okay, what that's going to give you is negative 1. All right, why is it giving you negative 1? The short answer is because there's no parentheses. All right, and so what's going on is just 6 is being raised to the power. That's how you get this 1 right here. All right, so that 6 raised to the 0 power is giving you the 1, but then that negative just carries over into our answer, like that. The difference is if the problem said this, negative 6 raised to the 0 power. That one, this is a single number raised to the 0 power, so that's equal to 1. All right, and then I could have something like y over 8 raised to the 12th power, like that. Well, what's going on here? I have a division or a fraction raised to a exponent, so that's exponent law 6 coming into play, that I can distribute that exponent onto each part. And so I got to remember it was 12, not 2. Sorry, I wrote over my 12. So I would distribute that 12 onto each part there, and then as an exponent. So I have y to the 12th over 8 to the 12th. All right, and you might want to just look at this to see, but 8 raised to the 12th power is this huge number. Your calculator gives it in what's called scientific notation, and so you don't want to try to write that number out, and so you could just leave it that way. All right, and then you might have to end up combining some exponent laws too. So say I had something like 2x over y squared raised to the 5th, like that. Okay, now you just got to be careful on this. This is a fraction raised to an exponent, so I can distribute this exponent onto each part. But the key thing is you're distributing it onto the entire part. Okay, so going from here to here, we're going to use law 6. All right, and so, but the key thing is you're not just raising, see, if I write this 2x to the 5th, I'm just raising x to the 5th power there. So I got to emphasize that I'm actually raising 2x to the 5th power. And then here I have y squared raised to the 5th. Okay, and so we're going to have to combine some exponent laws here. And so the key thing is these are some of our earlier exponent laws. Here I'm multiplying and raising to an exponent. So that's going to be exponent law 3 that allows me to distribute that 5 onto each one. Okay, so up in my numerator, I'm going to be using law 3. All right, and so that's going to give me 2 to the 5th times x to the 5th. All right, but in the denominator, though, I have a completely different story. I have an exponent, something with an exponent raised to an exponent. So I'm going to be using a completely different law there. Going from here to here, I'm going to be using law 2. All right, an exponent raised to an exponent, you multiply the exponent. So I have y to the 2 times 5. Okay, 2 to the 5th is a reasonable number to compute. That's 32. So, and then we have x to the 5th, and then down in the bottom we have y to the 10th. All right, and so with that, and let me just do one more that I just thought of, and then we'll call this a video. All right, so what if I have negative 2 over x squared y cubed, but then I want to raise this whole thing to the 3rd power. Ay, ay, ay. Okay, the key thing is the basic form is that you have a fraction raised to an exponent. Okay, so the first thing you can do is apply law 6 and distribute that exponent onto each part. All right, and so the key thing is, what am I raising to the 3rd power? Negative 2. Okay, like that. And then I have x squared y cubed raised to the 3rd. All right, so now negative 2 raised to the 3rd, that's just a number, so I can do negative 8. All right, and now for the denominator, though, what do we have? We're multiplying two things and then raising that to an exponent. So we have a product raised to an exponent, so we're going to use law 3 right here. And what does that mean? We distribute that exponent onto each part. All right, and so we end up with x squared to the 3rd times y to the 3rd to the 3rd. Okay, and so now what do we have? In the denominator here, we have 2 instances of something with an exponent raised to an exponent. So I'm going to have to apply law 2 onto each one of those parts. So you can see it gets quite a bit tricky on some of these. All right, so we have negative 8 in the top. We have x squared to the 3rd. We multiply the exponent, so we get x to the 6th. And then we have y cubed raised to the 3rd. We multiply exponents, and we don't get x, though. We get y to the 9th. And then that would be the answer. Okay, so I hope that helps. Good luck to you.